Chapter 2, Section 6. Finished up the chapter today. We're talking about absolute values today. A little bit bright in here today. And kind of punch out a bunch of videos. So you're going to see a lot of outfits. A lot of the same outfit, probably. Try to get 3 or 4 different videos done to cover the next couple of weeks. So, yeah, before we head into this realm of wonderful distance learning. So today, we're going to use the distance definition of absolute value. We're going to solve absolute values in the form the absolute value of a of x plus b equals k for all k values greater than 0. Solving inequalities in the form absolute value of a of x plus b is less than k, and the form a of x plus b is greater than k for k greater than 0. And then solve absolute value equations involving rewriting. So we're just going to do those first 4 objectives in this lesson today. All right, so let's start out by using the definition of absolute, the distance definition for absolute value. So essentially, what absolute value is absolute value of a number x written, absolute value of x is the distance x is from 0 on the number line. So now kind of the key in here is distance. We know distance is always going to be measured in the positive. You don't run negative distances. Football players lose yards, but they still lose positive things. I mean, it's not like, So distance is always going to be this positive thing. So absolute value is the distance x is from something on the number line. So if we look at finding like the absolute value of x, or the absolute value of 5, the absolute value of 5 is 5 and negative 5. So you can kind of see below, if I put negative 5 and 5 on the number line, the distance both of those are from 0 on this number line, this distance is 5. And that's what absolute value is. It's that distance that we are from 0 on that number line. Okay, so that's what absolute value is the distance, positive distance from 0 on the number line. So there are several different types of absolute value equations and inequalities, and the way we're going to go about solving them is like this. So if we have the absolute value of a of x plus b is equal to k, we're going to solve a compound equation. So we're essentially going to make it 2 equations. We're going to make it a of ax plus b equals k and ax plus b equals negative k. And then we're going to write the solution set in interval notation. Okay, and put our dots on the number lines and so on and so forth. Well, we'll put it in this form. Okay, not really interval notation, but we're going to put it in that form right there. To solve absolute values that deal with inequalities, there's 2 different ways to do it. If it is greater than, so the absolute value of a of x plus b is greater than b, then we're going to solve the compound inequality a of x plus b is greater than k, or a of x plus b is less than negative k. And again, noticing just like up above, we change that symbol on the second time, and we've talked about it in the past. If we multiply something by a negative, we switch the symbol, so that symbol is going to switch around as well. Then we're going to write the solution set from negative infinity to p, the union q to infinity, which consists of 2 separate intervals, so they're generally speaking going to go out from each other. And or, remember we talked about the other day, ors go out. And that kind of greater, it's an or statement, so you're going to do 2 statements combined with or if it's greater. If it's less than, and solve the absolute value of a of x plus b is less than, and k, you're going to solve a 3-part inequality. So you're going to do the solution set is negative k is less than a of x plus b, which is less than k. So the inequality symbols are both going to go the same, still going to go the same direction, but now we're going to have a negative k on the left-hand side and k on the right-hand side. And then we're going to put a single set in interval form. All right, so let's do some practice. So let's solve some equations that are in the form a absolute value of a of x plus b is equal to k for k greater than 0. So to solve 3x minus 4 equals 0, we're going to set it up as 2 equations. We're going to go 3x minus 4 equals 11, and 3x minus 4 equals negative 11. And we're going to go ahead and solve. So plus 4 So 3x equals 15, x equals 5, add 4, 3x equals negative 7, x equals negative 7/3. So our solutions to this is negative 7/3 and 5. That's kind of our solution set, and that's our answer. If you're asked to graph this on the number line, which I don't know if you're going to be asked to do this today or not, just kind of, it's there and there. Okay, so it's solving two equations, essentially, one positive and one's negative, because remember that absolute value means that we could make that middle negative 11, because distance is what absolute value is. So kind of keep that in mind. Anytime you're dealing with absolute value, you're probably going to end up solving two different equations when you're doing these today. Okay, so there's rationale. Okay, let me just get one example of that. Wow, that's all right. Okay, so now let's look at solving inequalities in the form a of x plus b is less than k, and in the form a of x plus b is greater than k, for k is greater than 0. So let's start with greater than. So we talked about it earlier. Greater means or. We're going to put these together with the word or. So we're going to go 3x minus 4 is greater than or equal to 11, or 3x minus 4 is less than or equal to negative 11. Greater means we're going to put them together with the or symbol. We write the first one out just how it's supposed to be. The second one, we change the inequality symbol and the value of it. Got that shadows like right in my eyeballs right now. Kind of weird. Kind of a raccoony look. Anyway, so now you just solve, just like we did before. So add 4. 3x is greater than or equal to 15. X is greater than or equal to 5. Plus 4, plus 4. Nice 4 there. So you get 3x is less than or equal to negative 7. 3x is less than or equal to negative 7/3. So when we're doing with inequalities, I like to graph the inequalities first. There's 0, there's 5. It says x is greater or equal to 5. So that means that we are going to have a bracket, and it's going to go off to infinity. So there's our first one. Negative 7/3 is right there, and it's less than or equal to, so that means we're going to have a bracket there. So there is our graph. Now we're going to go ahead and do the inequality. Inequalities, when I do inequalities, or when I do my interval notation, when I do the interval notation, I just kind of start at the far left-hand side. So it goes from negative infinity to negative 7/3. Can't go past that. And then it goes from 5 to infinity. And again, brackets because it's greater than or equal to or less than or equal to, and parentheses around our infinities because that's how you always do them. So there's our interval notation for them and the graph of that one. Okay, go through theirs real quick. And again, same answers that we had. They put the symbol in between them, but you can put the symbol in there as well. Okay. Now this one is less than. So we got 3x minus 4, same equation we've been doing all along, but now it's less than. So when we're doing less than, we're going to go with negative 11. We're going to take that symbol. So if it would have been greater than or equal to, or less than or equal to, we would have used less than or equal to. But it's just less than. So we've got, let's try this again. So we've got negative 11 is less than. Now we're going to put our expression as less than 11. Now we're going to add 4. And we did these the other day when we did these inequalities. That's negative 7. 3x. 15. Negative 7/3. X. 5. So the graph. There's negative 7/3. There's 5. They're parentheses, and x is between them now. So x is going to be between them. So since x is between them, I'm going to go a parenthesis there, and I'm going to go a parentheses there. And we're going to fill all of this in. So our interval notation goes from -7/3 to 5. And those are where all our solutions are for that. So there's a less than. Okay, so equals to two equations. Greater, two inequalities, one positive, one negative. And then we've got this one with the or statement. Okay, so let's look at theirs real quick. Same thing we had, they just do the graph after. Okay, so now let's just look at a little bit more complicated questions where we have to do a little bit more than one step with these, but nothing big. So we've got the absolute value of 3a plus 2 plus 4 is equal to 15. Step one with these is you're going to isolate that absolute value, just like we kind of always do when we isolate square roots, we isolate everything. We try to isolate the absolute value. So we're going to isolate that absolute value first. So I'm going to subtract 4 from both sides. So we've got 3a plus 2. The absolute value of 3a plus 2 is equal to 11. Now we've got an equation, so two answers. So 3a plus 2 is equal to 11. And 3a plus 2 is equal to -11. This is going to be an and statement. School's supposed to start like in 5 minutes. Subtract 2. And you'll notice you do the same thing on both equations both times. So you get 3a equals 9, a equals 3, nice a by the way. And then 3a equals -13, a equals -13/3. So there are your two solutions. To write these, you write them as a solution set. The smaller of the two numbers preferred to go on the left-hand side, but it doesn't have to. There's your solution. Okay, so isolate that absolute value. Once you've got that absolute value isolated, just go ahead then and solve. Okay, they rewrote it or instead of and, but that's okay. Okay, when we're doing inequalities, same thing. And we're going to isolate first. So we've got the absolute value of x plus 2 less than 5. It's going to lead to an interesting question we're going to talk about here in just a second. So it's greater than, so we're going to have an or statement. So if we have a greater than statement, x plus 2 is greater than 5. X plus 2 is greater than, is less than -5. So subtract 2. X is greater than 3. Subtract 2. X is less than -7. So our graph, again, I like to graph them first. There's 0. There's 3. It says x is greater than 3, so that's a parenthesis. And off in this direction. It's less than -7, so there's -7. It's a parenthesis off in that direction. So our interval goes from -infinity to 7 and it's parentheses, and then from 3 to infinity. And there are our solutions. I said it kind of leads to an interesting question. If we had something like the absolute value of x plus 2 is less than -4, can that ever happen? Can the absolute value of something ever be negative? Well, absolute value is the distance, so can it be less than a negative number? Nope. No solution for that type of question. I think we maybe have one more. Okay. Last one, it's less than. So again, absolute value, go ahead and isolate it first. So by subtracting 4. So we get 11. Now, how do you remember if you separate them or put them together? I kind of look at the symbol. When you get the symbol less than or equal to, that means I'm going to go -11 because my symbol is always going to face the same way. if you had something like, so that's the way we're going to write it. And notice the symbol is kind of always opening up. Our mouth is kind of always opening up to the right. If we have 3x plus 2 is greater than, again, that's an or statement, and we're going to always use the or. But we always want to, if it's opening this way, we're going to go kind of in this line of things, so to say. Okay, so subtract 2. Negative 13 is less than or equal to 3x, less than or equal to 9. Divide by 3. So negative 13 thirds is less than or equal to x is less than or equal to 3. Graph it real quick. There's negative 13 thirds. It's a bracket. There's 3. It's a bracket. All of our solutions are in here. Interval notation, we've got a bracket, goes from negative 13 thirds to 3. There are our solutions for this. And you can probably include that one in there too. So when you're doing your assignment today, really what you're going to be looking at is really these 3 or 4 different types of equations where you're going to go ahead and solve, we're not going to do those, where you're going to go ahead and solve absolute values that are equal, less than, or greater than. So really the 3 types of problems you're going to have today. When you're looking at them, you are going to be asked to list the solution set if it's an equal, or you're going to be asked to list the interval if it's greater than or less than, or those types of things, and you're going to be asked to put the graph together for them kind of as well. So about 10 problems, 11 problems I think in the assignment today. Should be a rather quick one. It was a rather quick lesson today. So we will see you on the other side.